are you, everybody who is watching this video? My name is Olenjolaim TAYAI from Tanzania. My name is Olenjolaim TAYAI from Tanzania. In simple, just call me Olenjolaim. So I would like to welcome, and I'm very happy to welcome, whether you are a national student of undergraduate level in United Republic of Tanzania or any other level, equivalent levels, etc., etc., or you are an international student from any continent in the world, because this material are relevant and useful and helping millions of undergraduate students worldwide for the present and future generation. All of you, I would like to welcome you into our online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Simultaneously, because I'm teaching engineering, higher engineering mathematics and the higher scientific mathematics, I would like to welcome you into one of our official YouTube channel called the Online Undergrad Polyinstit of Tanzania in square bracket OLENJOLAIM. Well, it's kind of something, I know that possibly this might be your first video, or it might be your first video, and it's the first time to meet with me and first time to hear about the things that I'm trying to convince you to understand. Let me clarify and help you at least to be close to the point. Well, the word of God, which is the word of truth, say that if there is no vision, people perish. So if I'm doing something, or if I'm living in Tanzania right now, and then I don't have any vision in Tanzania of living in Tanzania, then I'm going to perish. However, that I'm a citizen of Tanzania. So when I've been receiving this idea, because this idea of teaching nationally and even internationally wasn't in my mind. I didn't expect. I didn't even think about, because I knew even if that I think I won't be able to make it happen. So God has given me this vision in my mind, and I would like to write it into your mind also as my student, as a viewer, as the hobbyist of mathematics, as a hobbyist of engineering, hobbyist of science, as a worker, as my alumni, regardless of your present status right now. But this is the vision that God has revealed in my mind as the picture. And God has told me that I have to prepare, to train, to incubate, to incubate, to lead, and even to govern, and also to incubate some group of undergraduate students who will be ready to take the classroom instructions or the classroom knowledge in engineering mathematics, in scientific mathematics, in the year course. It means that the year we call this core courses, or according to the year programs, to combine with the knowledge and wisdom of the Word of God from the Bible in order to solve real life problems in our communities and even internationally. If you can penetrate and you can break the borders and cross the borders for that service, because even other nations also they are cross borders and bring solutions of our own problems. So our main objective in this program is not to help students to pass the final exam or continuous assessment. The primary and the fundamental and even the main objective of this program is to help our students to solve real life problems. For example, myself, I'm a product of classroom instructions. I've been trained in United Republic of Tanzania from standard 1 to undergraduate level in electronics and telecommunication engineering. Similarly, I'm also a student or a disciple of God through the Word of God, actually that's from the Bible, which are by the grace of God, I've been meditating it from the Genesis chapter 1 verse 1 to Revelation chapter 22 verse 21. So it doesn't mean that I know everything. Every year I have to read, I have to meditate the entire Bible, regardless of how busy am I. That's the conditions and that's the covenant between I and my God. So I'm also a product of the Word of God. So now what happens? God has been teaching me to combine these two knowledge. The knowledge of invisible words, that is spiritual words spoken in the word of God, and the knowledge of the physical world that we use to earn or to get it in the physical schools, or even in online schools, or in any kinds of the school that we are taking about the home schools, etc., etc. So myself, I'm a product of both areas of learning, spiritual, and even formal academician, right? So I'm solving a real life problems. This has been prepared for me to solve. However, that there are some other teachers also might be solving in their different perspective. But for me, I know that this is an assignment which I have, right? That's a very important piece of information that I wanted to share with you. So that's why. So myself, I'm already thinking, how can I use the knowledge I have from the Word of God and the classroom instruction to solve real life problems, not to pass exam. I've already passed all the exams. I don't have any physics exams or any kinds of the test or whatever. So that's the main objective of this program. However, that we have some specific objective. One is a specific objective, first of all, to make all our students to love higher engineering and scientific mathematics. Second specific objective also like to help all our students to pass the year continuous assessment. Third specific objective, we like also to train and teach and even reveal the secrets and simplify the contents. So all our students will pass the university exam and even the university exam, and even some of the colleges or universities, the quality final exam, right? So those are the three specific objectives. But the fourth specific objective, we are going to teach you to think differently and to see the potential that hidden in you, right? That's the fourth specific objective. And the fifth specific objective, that we like also to see our students are successful. And the sixth specific objective, we like to challenge you that to think where you can apply the knowledge of mathematics you already know, and even the one that you are learning now, to solve the problems yourself. Don't complain about the government, don't complain about the educational system, right? So now let us go to the session. So quick review, that's the point that always I have to begin to link my previous lecture and today's lecture. Right? We are departments of higher engineering and scientific mathematics. The course of the model names is called Matrices and Basic Calculus at University of Jerusalem. This is the referential institution, University, College of Engineering and Information Technology, so called COICT in abbreviation, or COIT is called the COIT, College of Engineering and Technology. So this is MT 161, this is called. And then the chapter 1 is vector algebra. We have 6 topics or 6 chapters in this course. Lecture 3, this is lecture 3, that's chapter 1. Lecture 3 is called Terminologies of Vectors. Terminology of Vector. We have some terminologies of vector, and I want to reveal them, each terminology. So once we'll be using them, later on, when we're building the walls of the house of the vector, then you understand what we mean, and you won't get confused. So quick review, we have already posted or uploaded the technical language uploaded or posted lecture 00, which is called or titled as General Introductions of Matrices and the Basic Calculus. Also, we've already uploaded lecture 01, this lecture 1, which gives the general introductions of vector. Also, we have already uploaded or posted to you or sent to you or distributed worldwide lecture 2, which is titled as dimension, dimension and presentation of 40 of vector. So let me quickly review this session, this lecture 2. So in lecture 2, first of all, we define what the means of dimension, but we say that the fundamental vectors we can express them only in 2 dimensions to be enough for we as engineers. And the first one is called the 2-dimensional vector, and the second one is called the 3-dimensional vector or 3D. Okay? So if this is the case, that's the case. So 2-dimensional or 3-dimensional. Again, we discussed about how can you represent a vector. How can you represent a vector? So you can present a vector in two ways, right? Either geometrically. Remember that this is the contents of the curriculums or the sub-enabling outcomes, or we call it the course outlines of that course. Geometrically, or you can present a vector algebraical. Okay, algebraical. So geometrically, it means that for 2 dimension we can use x, y axis. For 3 dimension we can use x, y, and z axis. X, y, and z axis. And also algebraically we can use either point that for instance is x, y, or we can use that is, or algebraically against that is for the 2-dimensional, 3-dimensional, or you can have also 20 x, y, z. So this is algebraical, but also you can present a vector as xi plus yj plus zk. So those are the representations of the vector, and we covered this. I used to teach also ordinary secondary students basic mathematics, and we used to teach them all of this information in advance. So let us come to today's lecture. And this lecture has been titled, the topic is vector algebra, and this lecture is again terminologies of vector. First of all, before I explain what does it mean with this phenomena, I would like before I explain the meanings of this terminology, I would like first of all you to be able to write this subtitle or some words in your mind so that you cannot forget them. Also, this course is for the first year and first semester of the first year in the science and the engineering courses. In case also you feel from your heart you want to offer your free will in thanksgiving to support this program, you may use this telephone number 0759745331, and your free will in thanksgiving will be received effectively, and it will be used obediently and fearfully before the presence of God. So in these terminologies of vectors, we have almost more than 7 terminologies, or around 7 terminologies, and I'll be explaining each of them and give you simple examples, and as we know. So the first terminology, we call it position vector. This is common term. Common term, you hear that this position vector, this distance between vectors, that is. So it's called the position. Say position vector. Say position vector. Okay? A position vector. So you have we'll be asking some questions ourselves. What is a position vector? So we say that is a vector whose initial point is origin. It means 0,0 for 2-dimensional, or 0,0,0 for 3-dimensional. And then is directly to a certain point. So that's the definition of what is position vector. What is position vector? Position vector, this is the vector whose initial point is origin. So its starting point is origin, and its end point is a certain point. And hence is a vector, that's why it should be directed. Okay? Okay. That the means of position vector. So for instance, geometrically, let me present it or show you position vector of 2-dimensional, which is a little bit simple compared to 3-dimensional if you show them geometrically, especially by using the hand. There is a computer, both two and three-dimensional can be shown. So position vector, that suppose that this is 1, 2, 3, 1, 2, 3, then -1, -2, -3, 1, 2, -1, -2. So then we have this point. This is origin. So here we have coordinate 0, 0. And here we have the directional vector. This is point A. So remember that this is x-axis. Don't get confused with the axis and whatever. And this is y-axis. So this position vector, for instance, for this case, is called the positional vector or A. So A indicating the initial point, A indicating the destination point. So you can have so many position vector, maybe you can have another position vector to this point. Okay, that point. So here it means that we have a direction and suppose that this is B. So it means that here also we have a position vector equal to or B. Alright? Also you can have another position vector which is in this direction. So this is vector C. So also this one we call the positional vector or C. Or indicating initial, it means that it begins at the origin. And B, that's the destination. I'm sorry that for my voice that may possibly is not clearly heard, but don't worry, I'll try my level best to make sure that you hear what I'm teaching you. So that's all about positional vector. So for figure figure 3, that's the figure 3.1. Okay. So say that positional vectors in figure in figure 3.1 are vector OA, vector OB, vector OC. Vector OC. So these are the examples of 14 positional vectors. That's the first terminology. So once we mention that there's a certain position vector which is parallel to a certain vector again of this nature, or maybe that find the unity vector which is parallel to the certain vector or the certain position vector. Should have that idea in your mind that positional vector, all the vectors are always begin from origin. That's the first terminology. Say first terminology. Let's go to the second terminology. Second terminology. Second terminology, I would like to teach you like to teach you, number 2, the terminologies that call the ecovectors. 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 What is the meaning of ecovectors? What is the meaning of So what the meaning of ecovectors? So ecovectors, we say that these are the vectors which have the same magnitude and the direction. So these are the vectors which have the same magnitude and the direction. Those vectors, we call them in mathematics ecovectors. These are the 2 vectors which have the same magnitude we see D to E. Okay? And here, this is positional vector. Not positional vector. This is just like a line saying to show the like of what of the vector. So these are the 2 vectors. So we say that the vector BC is so say vector BC is equal to vector B. So those are the ecovectors. These are the vectors which have the same magnitude but in different direction. No, the same magnitude and direction. We have the set terminology. Tell your neighbor the set terminology. Do you know the set terminology? Can you guess the set terminology? Can you try? Okay. The set terminology is opposite vector. Okay? So this is the opposite vectors. Opposite vectors. So opposite vectors are the vectors excuse me, opposite vector So as a definition, opposite vectors are the vectors which have the same, the same magnitude, both have the same magnitude, but different direction. While equal vectors have the same magnitude and the same direction. Okay? Are definitions of what? Of opposite vectors. You hear this term in the word problem. Okay? So say opposite vectors are the vectors which have the same magnitude, but different directions. So how do we draw that? Suppose that this is the initial point, like this. We have again another sketch to this. That is B to C, and also you have D to E. And here we have that this is the direction of vector in this direction. And here we have another direction. So you have either this direction or this direction. Okay? So this is the truth that we have to make sure that we understand once we are dealing with this stuff. I drew them back. Also that remember that they both have the same magnitude but different direction. So try to use, I think that they may draw them by using a ruler, right? If I believe that you're enjoying the beauty of engineering mathematics, high engineering mathematics, I do enjoy, and tell me in the comment section that you're enjoying this material from which institution, from which continent, from which country. So this is vector A, this is vector P, this is vector Q, okay, so PQR, yes. So here we have an arrow like this, and also here we have an arrow. So we find that vector PQ is opposite. Is opposite to what? Is opposite. Is opposite to another vector, which is SR. Okay, so it means that these are the two opposite vectors, and they have the way that we can write them as opposite vectors. For instance, that we say vector C is equal to vector B. The opposite vectors that we say, this one we call it the head, and this one called the tail of the vector. No, this is tail, and this is okay. So the life of mathematics, I'm teaching you about this contents called the terminologies of vectors. At this moment, I've taught you several terminologies of vectors, but I want just to explain to you quickly, because these are the stuff that you just learn them once, and then there's no need for you to revise it several times because it's already written in your subconscious mind. The first terminology is position vector. Position vector, this is the vector whose its initial or tail is at origins, and the end point, or we call the head of the vector, is a certain point in the plane, right? If you want to represent geometrically. And this is a representation. We have position vector A or B, vector or C. Those are the positional vectors in this figure. The second terminology is equal vectors. There are some vectors which are equal if and only if they have the same magnitude and same direction. So these are the two vectors which have the same magnitude and directions. We can have even equivectors, 3 equivectors, 4 equivectors, 5 vectors, and n equal vectors. So this is the representation that the distance from here to here is equal to distance from here to here, and the arrows are directly in the same direction. Also, we have opposite vectors. So these opposite vectors, you find that this is vector PQ, this is tail, this is head, and then this is PQ is opposite. So this is tail, this is head. So right now this is tail. So say tail, this is tail, okay, and then this is head. This is head. So mean that this equal to opposite vectors. These are the two vectors or 3 vectors or 4 vectors which have the same magnitude but different directions. For instance, that directions of this vector from P to Q and the direction of the second vector is from S to R. So these two vectors, we call them opposite vectors. Okay, so again, for instance, if you hear that maybe there's a certain vector which is, we say that you say if, for example, if vector A is opposite, if vector A is opposite to vector B, right, to vector B, then we represent this phenomena, represent this phenomena as vector A. So it's opposite, so we say that vector A is equal to negative vector B, or in other language you say that vector B this is equal to negative vector A. So these two vectors, once you see these notations, it means that those two vectors are opposite vectors. Okay? So we have again the first terminology, which we call the parallel vector. Parallel vector. Okay, parallel vectors. Parallel vectors. Okay, parallel vectors. Say parallel vectors. So these parallel vectors are a little bit different compared to what we had in previous cases. Okay, so now let us go to the first terminology of vectors for higher engineering and the scientific mathematics. As I say that this contains for undergraduate students, and especially those students who are pursuing undergraduate studies or bachelor studies at University of Dar es Salaam College of Engineering and Technology, that's called the COET, right? That's the reference curriculum. But this material might be used in any institutions or college or University of Tanzania, or even in African universities and worldwide universities. So the first terminology we call parallel vectors. I want you to understand, because in Wendy problems we'll be saying that a certain vector is parallel to another vector and hence is perpendicular to another vector. So we'll be using these terminologies. That's why I want you to understand when I'm building the foundation vector in your mind. However, that you know these contents or lengths, but I want to remind you. So we say that the definition of the parallel vector is that if two vectors are said to be parallel, right? To be parallel, then this is the condition. Then one vector should be a scalar. Should be a scalar multiplication. A scalar multiplication of 40 of another vector. Should be a scalar multiplications of another vector. That's the concept, right? So I say that if two vectors are said to be parallel, then one vector between the two, one vector should be a scalar multiplications of another vector, right? What does it mean? I told you in lecture 1 about notation of the vector. But for instance, okay, example, suppose vector A is parallel to vector B. Then remember the condition. These two vectors are said to be parallel if, for instance, vector A is equal to the scalar multiplications of vector B. Or, in mathematics also we say, if those two vectors are parallel, also vector B, it can be a scalar multiplications of vector A. So under this, if the two vectors obey this condition, then we say those two vectors are parallel vector. So whereby this symbol, which is lambda, representing what is scalar quantity. I will teach you later in operation of vector scalar quantity. So one of operations we have scalar multiplication. Okay. So under that conditions, we say that those two vectors are parallel. But if we present it geometrically, right, in XY plane, parallel vectors always, they can be parallel vectors of the same direction or opposite direction, right? But suppose that this is a vector A, and also here we have another vector which is parallel vector B. So parallel vectors, the way that we present them geometrically is just like parallel lines. Parallel straight lines, those are the lines which never meets to infinity. That the means of parallel lines. So even in case of vectors, also we say that these two lines, if we draw them geometrically, they will never meet, and they have the constant distance between them. Right? Do you enjoy the beautiful higher engineering and scientific mathematics? Tell me in the comment sections of our official YouTube channel below there so we can get the feedback from you. So do you know what is next thing? The next terminology, that's the fifth terminology. The fifth terminology is very interesting now. Let me take you into the terminology that we call in vector lens. Say lens, or norm, or magnitude of a vector. How many names there have written? 3 names. Length, or norm, or magnitude of a vector. Right? Or size of the vector sometimes. So we say that, what is length? What is length? What the means of length of a vector? Right? Of a vector. What the means of the length of a vector? So length of a vector, we say that is the size of a vector. Right? Or it's a magnitude of a vector. Or it's what it, or it is a magnitude of a vector. Then this length of vector, which is also known as norm of a vector, is denoted as in vector we use this double notation. So this is the notations, not the, we don't confuse the notations of norm or length of a vector and modulus in the complex number, or modulus of the complex number. Don't confuse with that point. So we say that if, for instance, we say for two-dimensional vector, or we call it R square, we say that which is given as U is equal to the x components U1 and U2. So we say that the notation now, we notate that the length of vector U, this is equal to the length of what? Of vector U, because you have to be familiar with this notation. Okay? So the length, this is equal to the distance Okay, this is equal to distance. Distance is equal to what? So now not distance actually, that we say that according to the Pythagoras theorem, right? So we say that by using Pythagoras theorem, Pythagoras theorem, right? Pythagoras theorem in the xy plane, for instance, the xy plane, that suppose we have this xy plane like this, and that is y-axis, this is x-axis, and then suppose that we have a vector and they have a perpendicular line like this, right? So this is 0, or this is the origin, this is A, this is point B. So OB it's U1 for that case, and then AB it is U2, and this is the angle, right? So it is the angle. We say that this one, this is magnitude of vector U. So you see now my Pythagoras theorem, because I want you to understand my Pythagoras theorem, which is very important. Okay, Pythagoras theorem, you say that C is equal to A squared plus B squared. So what is our C there? Our C there is norm of U, which is magnitude of U squared. And then so what is our A? Our A possibility is U1 squared plus U2 squared. So then we have to find the square root to both sides of this equation. So norm of U, right? This is equal to what? Square root of U1 squared plus U2 squared. But this is for two-dimensional vector, right? So for three-dimensional vector, I taught you in lecture 2 the means of dimensions of the vector. Then we said that norms, for instance, that for three-dimensional vector, suppose that when we given vector U is equal to x component U1, y component U2, z component U3, then we say that norm of vector U, this is equal to the square root of what? Of U1 square plus U2 square plus U3 square. So this is norm of 40 of vector U, right? But again, I want just to take you further, because now you are a lover of mathematics and you are an undergraduate student. We say that two-dimensional vector will represent as r squared. Three-dimensional vectors will represent as r cubic, as three-dimensional figures. For instance, that maybe in editing or in video editing or in civil software, in any software that we have these kinds of the 3D, we call it 3D, is famous. So if we can have four-dimensional, then we can have r power 4. So then it means that we go. So now, if you have n dimension, this one in vector represents as what? As r power n. Right? So what does it mean? That for instance, we have a vector which has more than 3 dimensions. So for instance, U1, U2, U3, this is as dimensional, and then comma dash dash dash, and then we say comma UN. How do we find this norm? So for this case, we say that it's norm for U. This is equal to, or length is equal to square root of the first component square plus second component square plus third component square plus dash 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 3 dash plus u power n square. So this is the formula of finding length of the n dimension. So this we call T n dimension of a vector. Okay, n dimension of a vector. So that is all about length or norm or magnitude. But I have an example. No, I will have an example later on. Yes, I have an example. So because in lecture 2, I gave you a homework, which I called it homework 2, because it was in session 2. This will be example 2, right? So this example 2, simple, very simple, ask you that find the length of what? Length of vector v. Find the length of vector v, given that vector v is represented as geometrical vector, which is -1, 4, 7. Okay? 7. Then we say that solution. Okay, solution. How do we find the length of that vector? Simple. So no need even for the steps. Just recall the formula. This will be our first step. Remember that I told you I'm building the foundation. We'll go into complex and complexity issues of matrices and basic calculus as we continue with these lectures. Recall the formula. We say that if we have norm of Serre components, we say that we can find magnitude as the first component square, second component square, and third component square. So if that's the case, so we say that norm of V, for this case, it will be what? The first component of V is -1 square plus what? 4 square plus 7 square, right? And then we say that norms of V, or magnitude of V, -1 square, this is equal to what? Is equal to 1 plus 4 square is equal to 16 plus 7 square is equal to 49. So 49 plus 1 is 50. 50 plus 16 is equal to what? Is equal to 50 plus is equal to 66. So the answer is under root of 66. You can use your scientific calculator to compute the answer in decimal numbers. But you can even end there numerically. So this is the length of vector V. Okay, so that's the fifth sortie. That's the 50 terminology. Then I have again the sixth terminology. The sixth terminology, you know, just like in complex number. When we learned about modulus, we thought against about argand diagram, so it means argand or angle. So we have the sixth terminology here. And this sixth terminology called the angle, or direction of a vector. Interesting. Means that a vector, it can make an angle, or that angle we call it in mathematics also as what direction. So before I teach you how do we find that angle, consider the figure 3.3 below, and this technique will be limited only for the two-dimensional vector. This is y-axis, this is x-axis, this is origin. Okay, so we say that we want, suppose that we have a positional vector here, and this positional vector is positional vector OA, which is two-dimensional, contains x components and y component, and here we have an angle theta, right? So we can prolong and have a right angle triangle here. So once you have a right angle triangle, then the issue of computing the angle, the magnitude of the angle, becomes simple. Why? Because there are some mathematicians who have already answered that question. So it means that suppose that this is going to be, so we have AB and OB, so this is y components and this is x component, right? Y components and that is x component. So if that's the case, we say that If you consider that rectangle triangle, say, we can have a tangent. Say tan of angle theta is equal to opposite over adjacent. Just to remind you, what the opposite of this angle? The opposite of this angle is y, right? And then what the adjacent of the angle theta? The adjacent is x. So y over x. So then this is tan of angle theta is equal to y over x. So then divide it by tangent and divide this one by 1 over tangent. So theta, this is equal to 1 over tan, but we have y over x. In mathematics, 1 over tan, this is equal to arc of the tangent of y over x, y over x. But also, in other words, this in mathematics is equal to tan inverse of y over x. So these are the two formulas that we use in mathematics to find the angle of a vector. Remember that this is a vector. So because the vector should have both magnitude and direction. And for instance, if you want to deal with magnitude of this vector, the magnitude of position of vector OA. Right? Position of vector OA. So this is the angle of a vector. Angle made between the vector and the horizontal axis. And this is limited. In case of the three-dimensional, in mathematics you have techniques we call directional cosine, which will help us to find angles in all the three axes. But that directional cosine is beyond of these course. Okay? Some of the courses are beyond of this course. The contest didn't ask me to teach you directional cosine, however that I know it. Okay? So then we have the seventh terminology. Say seventh terminology. So the seventh terminology right now is our bestie friend. Our bestie friend, whose name is called the whose name is called the distance vector. Distance vector. Or distance between 2 points. We call it displacement of a vector. Displacement of a vector. I'm about to finish this session. I still have only two terminologies. Displacement of a vector, or some of the books called the distance between, in short, between 2 points. 2 points. So after this seventh terminology, I will have the last or the eighth terminology. Then I will end this session. Okay? So distance, or called the vector between 2 points. Okay, distance between 2 points. So what is this? So displacement of the vector, we say that of one point from another point is defined by giving the distance of them and direction. So we say that simply say that displacement of a vector is the distance between the vectorial distance between 2 points. 2 points in space of the plane. Okay, so this are the distance between 2 points in space of the plane. What does it mean? It means that those 2 points are, it means that none of the point is origin. That's the means of space. None of these 2 points, none of the point is what is located at the original of XY plane. So for instance, this is y-axis and this is the x-axis, right? This is the x-axis. Okay, this is origin. So what do we say? For instance, that we say we want to show this displacement vector. This is the distance between 2 points, but because this vector also tells direction. So this is point B, point C. Also you can have maybe a distance between these 2 points. This is distance between point P to Q. If I put directions, then it's no longer distance, it's a vector between 2 points. Also you can have again another displacement of a vector between point R and S, but possibly that directions is this. So all of these are displacement vector. So this is figure 3.4 shows what displacement of a vector. So we say that for this case, for instance, we say BC, vector BC, and also vector PQ, and vector RS, now SR, are displacement. This is called displacement vectors. Are displacement vectors. Okay? Are displacement vector. But the meaning. For instance, that if you say that BC, this is unequal to CB in terms of direction. Okay? Displacement vectors. Okay? So, and I will tell you why. So for instance, that you say that suppose that point A, or suppose that for instance for this case, point B is given as x1, y1, z1, and point C, this is given as x2, y2, z2, right? So to find displacement vector BC, listen carefully. What the meaning first of all of this vector? The tail of the vector is at point B, and the head is at point C. So for instance, for this case, the tail of the vector is going to be the head is point C. While here it means we reversed. The tail is at point C, the head is at point B. So these two vectors may be the same in magnitude, but opposite direction. Right? So for instance, if we've been given that vector B, the components of vector B and vector C are this. So to find vector BC, displacement vector BC, then we have to take components of the heading point. Heading point means that components of vector C, right? Opposition of vector C minus components of vector B. What does it mean? Displacement vector BC for this case is equal to what? So it will be equal to x2 minus x1, comma, y2 minus y1, comma, z2 minus z1. Okay? So x2 minus x1, y2 minus y1, z2 minus z1. So so here we can formulate our displacement vector. So for instance, if you want to write in terms of positional or standard unity vectors, we can have that for this case to be x2 minus x1 I plus what? Plus y2 minus y1 j plus what? Plus z2 minus z1 k. Alright? Okay, so that is displacement vector. Okay, this is all about displacement vector, whether of the two-dimensional or of the three-dimensional. So let me give you one of the example, and then we continue with the joy of vectors in mathematics. Okay, then after finding that we left the homework, I'll teach the last terminology, and then we'll continue. So this is example 3. The question said that find the magnitude and displacement of vectors AC. Vector AC and vector CA. Vector CA, right? Given that point A is equal to -2, -3, 1. Point C, this is equal to -4, 1, -2. Okay? Interesting. So find the magnitude and displacement of vector AC and vector CA, given that those are the points. So solution. This is a simple question for undergraduate student. So vector AC, so to find magnitude first of all, so remember the norm, we notate by using this symbol AC, is the norm. So the norm, so we say that these are from the formula, we say for this case, it's x2 minus x1 square by using Pythagoras. Again, we say that y2 minus y1 square plus what? Okay, this is for 2-dimensional. For 3-dimensional, we say that for AC, norm of AC or magnitude of AC will be equal to x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Okay? Okay, so this is the formula for AC. Okay, so now the norm or the magnitude of vector AC, we have to take coordinates of point C minus coordinates of point A. So what are the coordinates of point C? I have to take -4 minus -2, and then I square plus what? Plus 1 minus 3 square, again plus what? -2 because of space, minus 1 square. So simply say that norm of AC, this is equal to square root. Negative is positive, 2 plus -4 is equal to -2. If you square, you get 4. Then plus -2 square is equal to 4. Then plus -2 minus 1 is equal to -3. If you square, you get 9. So 8 plus 9 is equal to 17. So the magnitude of vector AC is equal to square root of 17. Okay? Square root of 17. Displacement is 17. Write a little bit. So here we have -3, 1. So 1 minus negative. Okay, so here it will be plus. Because it is 1 minus -3. So it will be 4. So here it will be 4 square, so it will be 16. 16 plus 4, 20, so it will be 29. Thank you, Pat, for reminding me. Okay, so that's the norm. And then we have to find displacement, right? So for this, to find what the CA, this will be your homework. Okay? So to find displacement now of vector AC, you take coordinates of position of vector OC minus coordinates of position of vector OA. How do we do that? So as you say from the formula, that we take x2 minus x1, right? Comma, y2 minus y1, comma, z2 minus z1. Okay? So we say that displacement vector AC. So this will make us what? So let us take the first two coordinates of vector C, which is -4, right? So we take -4, we subtract with the first coordinates of vector A, which is x coordinates, which is -2, and then we don't square, and this don't confuse its magnitude. So we take the y components, which is 1 minus -3, okay, and then you can take -2 minus 1, but we don't square. So now displacement vector AC, or the distance between the two, it will be -4 plus 2. The answer is equal to what? -2. Then 1 minus -3, the answer is equal to 4. And then -2 minus 1. So -2 plus 1, this makes 3. So this is equal to +3. So because the vector will be given, it has been given vectorial, right? Vectorial, algebraically. So even the answer should be also in algebraic. Alternatively, you can find first the displacement vector like this. If you square each of these components and you find the square root, if you square the square root of each components, if you square -2, you get 4. If you square 4, you get 16. If you square 3, you get 9. So you can either find this displacement vector, and then you can use the displacement vector to find its magnitude. Right? Okay. So that's all about your displacement vector. So let me take you into the last terminology so that I can end this session as I gave you a promise. And this terminology is called the unity vector. Very important terminology in vector for undergraduate students, especially for the vector algebra. Unity vector. Say unity vector. Say unity vector. Okay? So the simple question that we have to ask ourselves as engineers, what is unity vector? Very important, because every vector has a unity vector. So what is unity vector? What is a peculiar characteristic of unity vector? So you say unity vector, you say that is any vector, this is any vector whose magnitude is 1. Whose magnitude is what? Is 1. That's the meaning of what? Of unity vector. So every vector has a unity vector. It is denoted as this. So suppose that if this is a vector, and then we use this notation. So for that to say, if you have vector U and it has two components, U1, U2, then we say that unity vector of U, this is equal to it. This is equal to, so it depends. So we say that you have unity vector U. Okay? Again, if you have V, V is equal to V1, V2, V3, because we're going to use U and the V alternative. So now the unity vector of V will be using this notation. Okay? So we say that the general formula of what? Of unity vector unity vector is given as, so this is given as so this is given as what? Suppose that we have vector u and we have to find its unit vector. We have to take vector u, we divide with its magnitude. That's all. So this is the formula for the unity vector u. In case of v, we say that unity vector v is equal to vector v divided by magnitude of vector v. So also the formula might be in this form. In some of the books we can write, they used to write the unity vector as this, that it is 1 over magnitude of vector u, you multiply with vector u. Also this is the formula, and it's frequently used to have this notation. Okay? So we say that we have taken note of this. A unity vector, for instance u, like this, is parallel to its original vector. What the original vector? V. So it means that simply we say u. We say that u, unity vector u, it can be parallel to our original vector u. So this is the concept that you have to bear in your mind, because sometimes it will help you to understand. And it is true. Why is it true? Suppose that you have a certain vector of a certain magnitude from point A in the xy plane, point B. So this is the vector. So this vector, it will have magnitude, and the name of the vector is vector AB. Right? So if this magnitude is greater than 1, then we say that, suppose that the distance from here to here, this is 1, or the distance is 1, or the magnitude is 1. Then we find that vector AC, for this case, because its magnitude is 1, is a unity vector. So because the unity vector, what the directions of this unity vector, it's the same with the directions of 40 original vector. So if that's the case, you say that a unity vector, this one is parallel to it, parallel to the original vector, which is AB, because it's a part of the line segment. Fantastic. Okay, so that's all about unity vector for this level, or for this stage right now. Let me solve one question and then I give the homework, and to be the end of this session. So let us solve example 4. Example 4. Example 4 is a little bit technique. If you don't understand the concept of parallel, I told you about parallel vector. So you have to employ, find vector of length 5 units, okay, which is parallel to the normal vector v 4, 7, 4. So we'll be given length of the vector, we'll be given the components of a vector in x, y, and z plane. So we've been asked to find another vector. We can draw this vector in three dimension, right? You can draw that vector in three dimension. When you draw this vector in three dimension, then you'll find that you can also determine the magnitude. because you know the distance from there already. But if you draw this vector on the 3 dimensions, which have x components of 4, y components of 7, and z components of 4, then you can notice that it will be a line. So it will be a certain line. And these certain lines, it can have a certain magnitude, because you find the magnitude here, it's large. So because it's large now, possibly from this point to this point is a unit distance. So this will be the unity vector of the entire vector. Right? So the unity vector of this vector v is the one of the vector which is parallel to vector v. Solution. Okay, solution. We give us magnitude of 4 to 5, or length of 5, which is parallel to that. So we say that, remember that a unity vector is parallel to its vector. So what does it mean? A unity vector v for this one simply to be parallel to the vector v. Right? What the formula of finding the unity vector? The formula, if you recall, so this is the first step in the 4 steps, and the second step, you have to recall the formula. Second step, you have to recall the formula. Which formula? V. This is equal to what? This is equal to V divided by the magnitude of V. Okay, magnitude of V, like this. Right? So, either the case that if you find the unity vector, this is equal to 1 over magnitude, which is length of V, multiplied by vector V. So to find the parallel vector, this will be 1 over, what's the magnitude have been given? That the magnitude of vector V is equal to 5, which is length. Right? So it will be 1 over 5, and then you have vector component, which is 4, 7, 4. So that is the answer of a parallel vector. Okay? And the answer of the parallel vector. So this vector will be parallel to vector v. Okay? So it's a very good moment now to many students when the teacher tells them this is the end of the session. Students are so happy, even if they understood nothing. So it's a time for homework survey. I have one question I want to give to you. The question is all about displacement. Find the vector AB. Find the vector AB from vector A, which is 1, negative 4, 7, to what? To vector B, which is negative 2, 5, 8. Okay? So do this question, very simple question. You can just do it quickly because you have built the foundations. You see that even the speed has been changing as long as we continue. And then after you do this homework, submit in the comment sections so that I can review your homework, and even some other students worldwide, they can see about your efforts for doing the homeworks that you've been assigned. So this is the end of lecture series of the first chapter that's called the vector algebra. And before I leave you, or before I end this session, I will just quickly have some few comments that I would like to make for you to get connected with this program. Firstly, I thank God who have given me this idea of existing problem, national and even internationally. As I always declare that I haven't thought in my mind that I will do something like this for the rest of my life. But God has been faithful. He revealed this idea long time, almost 5 years ago, and then He has been taking me from one step to another step. I thank Him also during the preparations of this session, during the teaching of this session, and even I thank God who have given you an opportunity to join me from the beginnings to the end of this lecture. And I believe that according to what you have got, if I invite you in the next lecture, that will be lecture 4 of vector algebra, or of the course called the matrices and basic calculus, I believe that we are going to be together. Again, I want to remind you, in case you want to offer your free willing thanksgiving in order to support the running cost for this program, so that many lectures of matrices and basic calculus will be in air, so you can have them, or you can go through them anywhere at any time without any amount or without too much of hassle. So I'm always praying for you, and also I insist you to pray also for me, so that you may do the purpose of God before we live into the cemetery or into the grave, where that we have kind of will be departure from this physical world, and we go to the invisible world. That actually that we as mankind, we used to think that something will happen there, but we have not ever experienced it. So may God bless you. See you in the next session.